Hello everyone, so today we're going to go through a very important technique which is completing the square. So sometimes it's useful to rewrite quadratic expressions by completing the squares. Again, quadratic expressions is anything that's written in the following form: ax squared plus bx plus c. Okay, where a is different. Perfect. So let's learn how to use this technique by applying the formula over here onto example or examples. Okay, complete the square for the expressions. So I can see this one. So my b in this case, so it does match this one, right? But my b's in this case is 8. So I'm gonna use this formula where it says x plus b over 2. So 8 over 2, right? And there is no x here, so it's squared minus 8 over 2, all that is squared, okay? And that is equal to x plus 4, simplifying the 8 over 2, minus 4 squared, and that gives you, as an answer, x plus 4 squared minus 16. So basically, we successfully completed the square for this expression, okay, using the formulae over here. So let's do the same thing for the next one, okay? So as you can see, this one is only applicable for x squared, okay? So in order to make it into this form, what can we do? We can factorize. Given that they share a common factor, 2 and minus 12, the common factor is 2, so I can factorize by 2. And hence I will retrieve this expression, so I can actually complete the square. Okay, x squared minus 6x, okay? And now I'm just gonna focus on the one over here, trying to make it look like this, okay? So 2x minus, so it says plus, but because my b here is minus 6, so plus, you can say plus minus 6 over 2 squared, okay? So this is the bracket, the big bracket, and this is the bracket from the new one, okay? Minus 6 over 2 squared. And then the big bracket over here. And this is 2, if we were to simplify, it's going to be 2x minus 3 squared minus, so minus 6 over 2 is minus 3, so it's going to be minus 9, okay? Again, so we can simplify this one further step. So this 2, if we were to expand it, it will expand onto this one and this one, okay? So one mistake students often make is when they write 2x minus 3 squared and they leave the 9 as it is. That is a big mistake. When I said the big brackets, it applies, minus 9 is inside that big bracket. So if we were to do the expansion, it should be minus 9 times 2, which is minus 18. Okay, so doing one more in this example, x squared minus 3x. So we're gonna simply apply the x plus or minus 3 over 2 squared minus 3 over 2 squared. Okay, so this is x minus 3 over 2 squared and minus 3 over 2 to the power of 2. It's minus 9 over 4. And I think we shall be done with this example. So let's move on to example 5, where we're gonna try to do the same thing pretty much. Write 3x squared plus 6x in the form px plus q squared plus r, where p and q and r are integers to be found. So basically, they're asking us to complete the squares in other terms. So let me write my expression here, and then we'll see what we can do with it. Okay, so as I said, the first step is to factorize because we want to retrieve this one over here, right? So 3. So the common factor between, so I'm going to focus on this. So the common factor is 3 between 3 and 6, x squared plus 2x, okay, plus 1. So 1 is on its own, we don't care about it. If we were to add it later to something else, we'll see where it's gonna get us to. But now I'm gonna focus on this one, okay? So this one, I can write it in this form over here. So I'm gonna do 3 and I'm gonna open my big bracket, okay? X plus 2 over 2 squared minus, so in this case b is 2 over 2 squared, okay? I close my big bracket and I plus the 1, okay? So simplifying whatever in this big one, x plus 1 squared minus 2 over 2 is minus 1 plus 1. And to avoid the mistake that students often make, which is when you expand, it applies also to the minus 1, as I said earlier with the previous one. 3x plus 1 squared minus 3 plus 1. So 1 minus 3 is minus 2. So 3x plus 1 squared minus 2. So in this case, my p is 3, q is 1, and r is minus 2. So see, it's easy. Like once you master this formula, you remember it, it'll be easy for you to apply it to any example. If you come across any example, you'll be able to do it. So we have 2 more questions in about completing the squares, so let's get started with them. So given that x squared plus 3x plus 6 equal to x plus a squared plus b, find the values of the constants a and b. So pretty much we're going to do the same thing as the previous question. So x plus 3x plus 6. This one might even be easier because we don't have to factorize or anything. So x plus 3 over 2. So my b in this case is 3 squared minus, so I need to minus 3 over 2 squared plus 6, because this one is equivalent to this one, and 6 is on its own, okay? So x plus 3 over 2 squared minus 9 over 4 plus 6. So 6 minus 9 over 4, x plus 3 over 2 squared minus 9 over 4, so gonna make it 24 times 4 times 6, so they can share the same denominator. So 24 minus 9, I guess, is 15. So x plus 3 over 2 squared minus, no, plus 15 over 4. Hence, in this case, a is 3 over 2, and b is 15 over 4. Okay, so let's move on to question 5. Write 2 plus 0.8 x minus 0.04 x squared in the following form. So 2 plus 0, 8x. So they're requiring us to complete the square. Be intimidated, but the 0 point whatever is the same kind of concepts being applied over and over and over. So what can I do now is, because I need to get it to like x squared plus bx, right? So there's something to be done. The same thing we've done earlier. It might not be very obvious here, but we're gonna do the same thing. We're gonna factorize by um, minus 0.04, so we can have x squared on its own. Okay, so 2 plus, or if you want to keep it in the earlier order, it's okay. So we can do this. We can rewrite it as this order so it's easy for you to see. So I'm just writing the same thing but in different orders, and I'm gonna factorize by 0.04. So x squared. So what do we multiply 0.04 by to get 0.8? The answer to this is to divide 0.8 over 0.04, which I should give you minus 20. So minus 20x. So I literally just factorize over there by minus 0.04, and if you were to multiply 20 by 0.04, it's going to give you 0.8. Okay, so now we can get on to work. So applying the formula, okay, so I'm going to have my big bracket over there, x minus 20 over 2 squared minus 20 over 2 squared is because in this case b is minus 20, so I'm applying the formula from earlier, and I'm gonna get this, and I'm gonna close my big bracket over there, and I'm gonna add my 2. Don't forget the 2. So now I'm gonna simplify x minus 10 squared minus 10, so it's minus 10 to the power of 2, which is minus 100 plus 2. Okay, so we're gonna multiply, we're gonna expand by minus 0.04, so x minus 10 squared, and don't forget to apply this to minus 100 as well, so minus 0.04 times minus 100 plus 2. So computing this, we get minus 0.04 x minus 10 squared. 0.04 times 100 is 4. Minus times minus, it's still gonna keep it as positive, so I'm gonna have plus 4 plus 2. Okay, so these two together is 6. So because I'm given this form over here, so it's okay to play with the order a bit. So 4 plus 2, I'm gonna put it forward over here, minus 0.04 x minus 10 squared. Reason I'm doing this so it's easy for me to identify A and B and C. So A is 6, B is 0.04, and C is minus 10. And yeah, we're done. So as you can see, no matter how tricky it might look, is the same method. So don't worry, just go ahead and do it. And this marks the end for today's lesson. I shall see you in the next one. Bye.